Hello friends, welcome to our channel. In this lecture, I would like to explain another example, that is example 7 based on the biaxial bending moments. So see the question here. Design the reinforcements in a short column 400 mm by 400 mm subjected to an ultimate axial load of 1600 kilonewton together with an ultimate moments of 120 kilonewton meter and 90 kilonewton meter about the major and minor axis respectively. Adopt M20 grade concrete and FE 450 HYSD bars. So this is the given example here. So first of all, write down the given data. So write down the given data. So what is given here? Size of the column. So size of the column is 400 by 600, which in terms of rectangle. If it will be 400 by 400 or 300 by 300, 600 by 600 means at that time it will be square column. But here based on the dimensions it will be rectangular column. Okay. Then subjected to an ultimate axial load of 1600 kilonewton, means here it will be given in terms of ultimate, means that is factored load, that is 1600 kilonewton. So if sometimes they will give directly service loads like that, so there you have to consider 1.5 times of that given load, then you will get a ultimate load. So here directly given the question itself. Then here also ultimate moment, that is 120 kilonewton meter, and again about the major and minor axis respectively. So major means I am taking in terms of x1 will value and MUY will be equal to 90 kilonewton meter. Okay. So the size of the column here it will be given 600 by 400. So observe the difference between the previous problem what we solved in the example 6 in our channel. So in the example 6 what happens? So they will give a load some x and again moment some x1 only along the major axis. But here in this question what is the difference means the moment is considering from both x axis and y axis, means about the major axis and minor axis respectively, means here two additional moments are acting on a particular column. This type of columns will be called as biaxial columns. So we have to solve this type of problems based on the biaxial condition. Here whenever one additional moment is developed, at that time you have to develop, one means uni, two means bi. So that is the difference between the previous problem and this problem. So we have to solve this problem based on the uniaxial condition. Already we solved that problem in the example 6 and uploaded in our channel also. So entire procedure will be same, but here whatever the loads will be given, like some 300 by 400 is the example, means there the moments only consider along the major axis, like some 400 to 500 to 300. So then you can consider only movement along one axis and use to solve this problem. But here in the biaxial moment you can consider one movement like this and again change the dimensions, like some, so this will be D here and this one will be B. Again we have to change the dimensions, like D will be equal to 400 and B will be equal to 600, and use to solve this model like both along x axis and y axis. That is the only difference between the previous uniaxial problem and this problem, that is biaxial problem. Then one more thing what you have to remember, in the question itself directly mentioned that this is a short column. So already in the example 5 I solved one model based on the axially loaded column. There they didn't mention in the question itself, that is this question comes under the short column or directly any column. So there they will ask that design a column which is based on the axially loaded column. Okay, that is design the column. So there in the question what they will mention in example 5, they will give an unsupported length of some particular value, So based on that, and again they will mention one condition, it will be braced. So based on the condition I told that effective length will be equal to k into L. Whether it will comes under braced means, so you can check the according to the condition. Each and everything I explained very clearly. What I want to add here means, so already in the question itself they will mention directly short in the example 7 here, but it doesn't mention means based on the unsupported length and dimensions you can check both directions like LE by D and LE by B, it will be less than 12 means then you can design this column based on the short column. Okay, so but here it will be mentioned directly, no problem. That is the reason we are going directly without checking all these conditions, but I am showing the difference between the previous examples what we solved and the present example. And default values will be given like FCK will be equal to 20 Newton per mm square and Fi will be equal to 415 Newton per mm square. And one more thing I will show you the graph also. See here, uh, observe here clearly. See here in this diagram. So here the moment acting on both, so here there will be axial loaded column and the moment acting along one will be x and another will be y. So you see the difference. See here the moments will be developed both on x axis and y axis, means two additional moments are developed. So that is the biaxial condition. Okay, so already I told you in the previous example, that is uniaxial column which is acting at some eccentricity, only one additional moments are developed. Okay, so here if you observe very clearly means there is an axial load which is acting exactly at the center, and if you want to find moment means here, so you can take a resultant moment, mr will be equal to this formula, moment along x square plus moment along y square, that one will be equal to here. And here also in the form of eccentricity you will get resultant moment, it will be x square plus ey square. At what distance it will be acting, the moment here each and everything will be shown clearly in this figure. You please observe this one. This is the axis of the bending, this is the possible neutral axis, and this is the x axis and this is y axis. From x axis at some eccentricity x, this moment will be acting. So and for y axis at some eccentricity y, the moment will be acting. So if you want resultant moment, you can take E equal to square root of x square plus y square, like that. Then see here, all like previous example, we used to solve this type of examples based on the SP16 charts. Otherwise, there will be lengthy calculations by using IS 456, which is very complicated by using IS 456 2000 code. Therefore, we are using here SP16 special publication charts, which there will be some interaction diagrams. Based on that, we have to solve these examples. So before going to the charts, first what you have to do means see the requirements in the question. So there will be Fi 450 Newton per mm square. Okay, Fi 450 Newton per mm square. And what you want still for selecting a graph. So I will show you the graph here. So this is the SP16 chart number 43. I am just showing one example. So what are the minimum conditions required for selecting a particular graph means, see here, this is a graph of chart number 43. So compression with bending, a rectangular section reinforcement distributed equally on four sides, means see here distribution will be equally here, means if you observe clearly means therefore reinforcement distributed equally on our four sides. But in the yesterday I shown you the model also like this, reinforcement distributed equally on two sides only. So there will be such type of graphs. So before going to solve a model, you please choose the condition, assume any graph such that according to our condition, whether you want reinforcement equally on all four sides or reinforcement equally on opposite faces, that is your first condition. So here I am choosing equally on 4 sides. So I am writing here. So I am choosing the condition like reinforcement equally on 4 sides. And one more thing will be F5 415. So like this there will be 215 graphs and 500 graphs also. Okay, if you observe clearly, there will be 250 graphs which is related to d dash by d of 20. If you go on like this, observe means, so there will be reinforcement equally on only one side. So what I told you here, this is related to F5 500 and reinforcement equally on opposite sides of d dash by d ratio 0.15. In the same sense, there will be square circular graphs also. So for that one you have below these graphs. Okay, for selection of a particular graph, what are the conditions still we have to require means, so F5 415, what is given in our question, I selected that one and I mentioned there, that is F5 415. And next step is, you clearly observe, for selection of the graph you require d dash by d also. So d means they will given in this way. So this is the biaxial problem I told you before itself. So take down the graph of diagram like this. So here your d will be equal to 600. So taken from here to here, okay, here to here, and your b will be equal to 300 mm. Okay, taken from here to here. And what about this d dash? D dash is the effective cover which is taken from the center of the diabar, which is taken from the center of the diabar to the extreme fiber. Okay, so from here to here it will be d dash, like on all sides. For I am talking about the major axis side, which is 600. Okay, if you want to go from minor axis along y means, then at that time, so along y axis, not major and minor, at that time you used to solve this one like 600 to 300. But here I am talking about this d dash. So this is the effective cover which is taken from the center. If you observe from the graph, see here it will be mentioned from the center like that exactly. Okay, so we people know the minimum requirement for selection of clear cover. Not I'm not talking about the effective clear cover, that is 40 mm. Means 40 mm taken clear cover means from this edge of the diabar to the extreme fiber, means to the last surface. So this is the small d I am mentioning here. Okay, and this is d dash and this is capital D. But if you want effective cover means, so you can taken from the center, means you have to assume the diabar like some 20. So if you assume diabar 20 means, from center you will get 10, like that your overall cover will be equal to 40 plus thus 20 by 2, which is equal to 50. But while talking about in the initial stages, if you assume 20 diabar, finally you will get some area of the steel will be equal to around some 3500. There definitely you are chosen one more word here, equally on all four sides. Means you have to choose equally on all four sides, means what are the bars minimum requirements? 4, that is equally on all faces. Or else if you choose 6 means you will get opposite faces, then at that time you have to go for 8, means one bar will be 4, next will be 8. And again if you choose 10 means you will get equally on only two sides, then at that time what you have to do, you can choose 12, then you will get equal on opposite sides like this. Okay, so this is not included here. So here 4, here 4, here 4 and here 4, means next number will be 12. Like that if you choose some 4, 8, 12, 16, then only you will get equally on all faces, otherwise you will get equally on only one sides. At that time you have to provide 4 bars of 32 also, it will not suited to this area, means then you have to provide 8 bars of 25 or 32. If you also not suited means again you can come from 12. So that is the reason the diabar will be higher. So for example I am choosing some 8 bars of 32, sorry, at least 25 minimum, you just take next level, that is 25. Okay, 8 bars of 25 in diameter. Okay, then what happens means, if I am choosing 25 dia, then how much effective cover you will get here? I am choosing 25 means, so clear cover will be 40 plus So sorry, I am choosing overall effective cover of 50 means in that I am finally choosing the dia bar of 25 means what happens means in this 50 minus 12.5 means 25 divided by 2, then you will get a clear cover of 37.5. So this is a small error, but what is the minimum required here? 40 mm. So just a 2.5 mm will be error. So that is not a big error, but it is better to take according to the clear cover. So I am what we know. So already in the column we have to mention clear cover will be equal to 40 mm means then it is better to keep that clear cover minimum 40 mm. So that is the reason what I mentioned suggesting means you take down some higher bar like d dash will be equal to 40 means I am choosing the dia bar of some 25 by 25. So if you see this one means you will get 52.5. Okay, so minimum clear cover is 52.5. If so, but we can't say exactly in the final stage. We use to select 25 bar or 32. So if you will get 52 like this means then go from up so approximate value of some 60 mm. So you please check the value for 60 mm also. What happens? So 40 plus 60 means 30 by 2. 32 means 32 by 2 means that is 60, which is 56 mm. Means that we are taking 50 cover minimum will be 60. So even though you selected 12 bars also, 32 dia also, it will be suited. That is the reason choosing of clear cover also sometimes very important. So I am choosing here 60 mm. If you want you can choose 52.5 mm minimum. So finally if you select 25 bars means it's okay. Otherwise we have to increase the bars and again decrease the diameter. Like that situations will be different in the final stage. That is the reason I am choosing some approximate value which is equal to 60 mm. If I am choosing this much of cover means maybe you can provide 32, 25 or 40, 20 bar whatever it will be suited. Okay, I think you can get a clear idea what I explained up to now. Then move to the next step. After selection of this one, so your d dash value will be equal to 60 mm. Okay, then what is the d by d ratio? 60 your 600 along major axis. So I am talking about x axis. Moments are considered about x axis. So it will cancel one, that is 0.10 means your d dash by d ratio will be 0.10 and we are choosing condition of reinforcement equally on four sides and one more condition is Fy 415 Newton per mm square. So such the type of chart in your SP16. See here, what about this graph? So this is given 400 and this is 600, but this graph is related to 0.05 and Fi 415. So see this graph which is chart number 44. So in this chart number 44 and which was page number 129 in your SP16. So page number, so it is better to note down 129. Okay, so this graph is related to d dash by d will be equal to 0.10 and Fi will be equal to 450 Newton per mm square and the reinforcement also equal on all sides. So here d will be equal to 600 and this one will be equal to 400. So based on this you can find out this area of the steel in the uniaxial condition. So already we people know that. So there will be two non-dimensional parameter. One will be equal to Pu by FCK BD. Another one will be equal to Mu by FCK BD square. So in the last problem, while we solving about based the example based on the uniaxial column, so both the conditions like Pu also given and Mu also given. If we simplify, you will get both the values like from 0 to up to some any value and 0 to up to some any value. And if we relate these two means you will get this curve value like P by FCK. Here what is the curve here? Okay, but here there will be two moments like mu in x direction is given, mu in y direction is given. Okay, at that time it is difficult to solve problem based on this mu directly. Therefore, so based on this pu and p, you have to relate this one directly. I will show you that one. And before going to that one, you please see the formula in the IS 456 which was given in class 39.6, that is member subjected to combined axial load and biaxial load. So that is mu x by mu x1 alpha to the power of n plus mu y by mu y1 plus whole to the power of n less than or equal to 0. So you please take down this formula first and then see here mu x and mu y are the moments along x and y axis, where mu x and mu y1, that is uniaxial movement capacity for an axial load of pu bending about x and y axis respectively. Means already in the given data mu x and mu y value will be there, but here what are the unknowns again? Alpha n, mu1, mu x1, these three are the unknown values what we have to find in this entire problem. Okay, first see the formula. Based on that one we have to relate this mu x1. So in this graph, so first find out the pu by fck bd value. So how much you will get? Pu value will be given as, that is 1600 kilonewton. So if it will be 1600 means in terms of kilonewton I am converting into newton, because your fck value is in terms of newton per mm square, divided by fck will be equal to 20 will be given into 400 by 100. How much you will get? If you simplify, you will get the value of 0.333. Okay, so your pu value will be equal to 0.333, so which lies between 0.3 to 0.4. That is first point. And second point is what I told you. You please based on this p by fck, you please find out this mu value. Okay, this mu value. So here, so based on this reinforcement, we have to find this mu value. So already I told you based on the p by fck. For that one, if you want to find out this p value, here there will be p in the formula from the chart. So assume some percentage of the reinforcement and then based on the provided area of the steel, then relate that one to the p by fck. I will show here. So your formula will be equal to AS will be equal to PBD by 100. Here adopt 1% of reinforcement where P equal to 1, like 1 into 400 by 600 divided by 100. So if you simplify this one, you will get around 2400 mm square. So for that one, please provide the dia bars. So reinforcement. So go for trial sections like trial 1. So assume some percentage of reinforcement like 8 bars of some 20 dia. How much you will get? Okay. So if you simplify this one, you will get like 8 into pi d square by 4, pi 20 square by 4. So you will get around 2512 mm square. So here required area will be 2400 and provided area will be 2512. So I am taking direct value like 8 bars of 20 mm which is suited for this particular problem. So already like so we are starting from equal on 4 sides, means we have to check 4 bars of 16, 4 bars of 20 dia and again 8 bars of 16 dia, 8 bars of 20 dia. So calculate the individual area of the steel, how much it will be getting. So whatever the value getting more than required, then you have to choose that particular dia. But why I am choosing 4, 8 means here we are choosing the option like reinforcement equally on all 4 sides like this. So 4 will be suited and again 8 also suited. So I am not taking 6. Why? Because 6 means it will be equally on only opposite sides. Then according to this condition, provide provide 8 bars of 20 dia. So therefore your area of the steel will be equal to 2512 mm square. So already from this formula relate this one, that is 2512 equal to, here P is your unknown, what we selected assumed percentage as 1, and again 400 into 600 by 100. If you simplify, you will get the P value as 1.04. Okay, so based on this, again relate the value of P by FCK, that is 1.04 by 20. Then you will get the value of 0.052. Means you obtain the both the values, like P by FCK will be equal to 0.052 and PU by FCK BD square, sorry, FCK B into D will be equal to 0.333. So if you relate these two values, then definitely we will get the MU by MU value, so which is in terms of FCK BD square. So you have to relate that one. So if you observe clearly, already we people know that so this is the curve for particular graph. So you already I told you, so your graph lies between this 0.3 to 0.4, therefore I am zooming this one, and this is the curve related to 0, and this is 0.02, 0.04, 0.06, means your value will be 0. P by FCK value will be equal to 0.052, means the curve will be taken somewhere here, like I am taking in between 0.5 to 0.4 to 0.6. So this is 0.4 and this is 0.06. Okay, and where this 0.3 to 0.4 means here 0.3, and every two digits there will be one line, like 0.3, 0.32, 34, 36, 384. Okay, so here this is 32 and this is 34. Your value is 0.33, means assume that your value lies between 0.32 to 33 somewhere here, that is 0.33. Like that I am extending my line, so where I am extending my line, so in between these two graphs, like somewhere 0.04 to 0.5, and there I am dropping, okay, down. See here, perpendicular down. So if I want to choose here in between these two values, but I am choosing dropping exactly along this line. So where it will relate, you please assume that one. See here, this is 0, 0.1, 0. So here the each and every decimal, one decimal, 0.1 decimal, there will be one line. So this is 0, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and sorry, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09. Okay, and this is 0.1. Okay, so here the value related perpendicularly we are dropping 0.09. You have to choose somewhere in between like this also. If you drop like this, means how much you will get, maybe some center which you will get around some 0.085. So maybe there is a chances of coming the value between 0.08 to 0.09. So I will show you the difference between both the values. If you choose 0.08, so what is that value which is related here? Mu by FCK BD square is 0.085 or 0.09. So take down both the values and check what you will find the difference. So if I am coming from first one, that is the reason I am taking MUX1 here, that is FCK BD square, which is equal to some 0.05. So find out this one. MUX1 will be equal to 0.085. Okay, 0.085 into FCK is 20 into P will be equal to 400, where D square will be equal to 600 whole square. And again, whatever the values you will have, it will be in terms of mm, and this will be in terms of Newton. So the values in terms of kilonewton meter. So therefore you will take into 10 to the power of minus 6. So here the values is in terms of mm, therefore take down in terms of meters, that one will be equal to 10 to the power of minus 6. So if you simplify this one, you will get the value around 245 kilonewton meter. And again, if you choose 0.09 in place of 0.085 and simplify the entire value, how much you will get here? So if you simplify around, you will get, for me it will getting 259.2 kilonewton meter. Means the moment will be somewhat higher than compared to the previous value. So if you choose 0.08 means again the moment will be decreasing. So it is better to choose higher value only, which is safe side. If the moment is higher means the providing area of the steel also higher. So if you are designing for higher moment means automatically whatever the reinforcement producing higher moment, it will resist the smaller moments. So if you choose 0.09 also okay, 0.085 also okay, 0.08 also okay. For me I am choosing here 0.085, which is 245 kilonewton meter. Then so whatever we are solving here, it will be around major axis like xx. Then in the same way we have to find out the entire problem based on the minor axis yy. Okay. Okay. See here, for moments about minor axis, that is yy. So here if you take yy means, that is already I told you, b will be equal to 600 and d will be equal to 400. Okay. Then what about d dash? So d dash also assume same 60 mm. If you want means you can assume 50 also, no problem. So what I told already, here we provided 20 bars like that. So for that you can take 50 and you will get some different curve. So here if I am choosing d dash means I will get different curve because here the dimensions will be decreasing. Then what about your d? It will be 400. So check the dimensions, d dash by d around 60 by 400. So how many times it will go? So I'm seeing that one, that is 60 by 400 will be equal to around 0.15. So that is for x axis the graph will be 0.10, for y axis the graph will be 0.15. So it is better I think. Why? Because in one problem itself we are using two graphs, therefore we will get two different ideas. Okay. See here, where is the graph? So that is chart number 45. Chart number 45. See here, this is the graph of 0.10 and this is the graph of 0.15. So this is chart number 45, which was page number 130. So it is better to remember page number 130. So this is chart number 44, which is page number 129. Okay. Then see here, and this graph is related to d dash by d will be equal to 0.15, Fi will be equal to 450 Newton per mm square, and this d values will be changes. Therefore, d dash by d ratio 0.15. Equally, the reinforcement equally on all four sides. For this one, what we have to do means in the same sense. So first point is, what is our first point? So it is better to find out Pu by FCK BD. So already Pu value FCK PD will be same like previous x axis only. Why? Because we are solving for the same problem. Therefore, whatever the value will get before, that is 0.333 only. Then again here, what about your P by FCK curve? So your P by FCK curve also, it will be 0.052. Why? Because again you can assume 1% of the steel, then find out the area of the steel, which is you will get to 4400. For that, if you have to provide means 8 bars of 20 dia equally on all forces, and again based on the P by FCK, you will get 1.04 only. Like that, for that one you will get 0.052. Means I am telling entire procedure will be same. If you want means you can solve, otherwise take down directly that value, like p by fck will be equal to 0.052 and pu by fck bd will be equal to 0.333. But for these two values you have to relate this graph, like d dash by d will be equal to 0.15. In the previous problem we seen for 0.10, but here we are checking the graph based on 0.15. So this is the graph of 0.15, and again in the same sense, that is the value lies here between 0.3 to 0.4, which is 0.1, and this is 2 and this is 4. So I am choosing somewhere in middle 0.33 like this. Then what is your curve? That is 0.052. So like this. So I am relating somewhere here. So exactly in the same line I shown the difference between both of these value. So this is between, this is 0.04 and this is 0.06. So I am choosing the curve in between these two and I am relating this one exactly for this particular line. So if I am dropping exactly for this particular lines, see here, so there will be same graph, like 1 decimal there will be 0.01 decimal, there will be one line 0 0.1. So this is 0.5 exactly in the middle. So I am counting from stopping 0.0 0.01 0.02 3 4 5 6 7 8. So this is 0.2 and this is 0.09 and this is 0.1. Means your mu by fck bd square value will be equal to 0.08. So already in the x axis we used to solve mu x1, and here in the y axis this one is related to mu y1. Okay, then solve this one. Mu y1 will be equal to fck bd square will be equal to 0.08. So solve this one, 0.08 into 20 into, so here b changes like 400 to 600 and d changes to 600 to 400 into 10 to the power of minus 6 as usually, and simplify you will get 153 kilonewton meter. Maybe somebody will choose some other values like 0.09 also. Why? Because the graph not only related to 0.08, maybe it will be related to some other value in between these graph, like some here to here, whatever the value you can choose and make it perpendicular drop. So whatever the value you will obtain, so for that value you have to find the reinforcement. Maybe you will get the difference of some 0.075 to 0.85 around, or 0.9 also sometimes. So I already calculated for 0.9. For that the moment will be equal to 173 kilonewton meter. If you solve for 0.08, the moment will be newton meter. Okay. However, you will get the overall value which is less than or equal to 1, what I shown in the IS code book. Okay, but if you take this one also you will get less than 1 only. If you take this one also you will get less value only. I check for both the values. Okay, then so your MUY value will be equal to, your MUY y1 value will be equal to 153 kilonewton meter. So take down some rough data, like MUX1 will be equal to, so MUX1 will be equal to how much? That one will be equal to 245 kilonewton meter. Mu y1 will be equal to around 153 kilonewton meter. And what about your formula? So your formula will be this one, that is mu x by mu x1. So here we find the mu x1 and mu y1 also based on the graph, but still there will be one more value which is pending here, that is alpha n. So if you want to find out this alpha n, see here alpha n is related to pu by, so this alpha n is related to pu by pz. Here the words will be small, pu by pz. So already we people know that is pu will be equal to 600 into 10 to the power of 3 newtons. And what about this PUZ? For that one, there will be clearly mentioned that one formula, that is PUZ will be equal to 0.45 FCKAC plus 0.75 ASC. Okay, so I will, based on that one, I am finding that PUZ. So what is the formula in the code book? That is PUZ will be equal to 0.45 Fi AAC plus 0.75 Fi AAC. So already we have all the data like 0, sorry, this is FCKAC in the code book, FCKAC. Check once whether you wrote correctly or not, which is FCKAC only. Okay, so 0.45 into FCK will be equal to 20, again AC is unknown here, plus 0.75, Fi is 415, and what about area of the steel? Area of the steel will be 2512, what we provided for 8 bars of 20 dia, which is equal to 2512 mm square. And again, what about AC? Already I shown you so many times, in the overall gross cross sectional area, you have area of the steel plus area of the concrete. So we know area of the steel. So based on this one, area of the steel will be equal to gross cross sectional area minus ASC. Sorry, AC. So we want AC value. Therefore, take down AC will be equal to gross cross sectional area minus ASC. So what is your gross cross sectional area? Your gross cross sectional area will be equal to 600 by 400 or 400 by 600 per square. But we are solving for circular one will be equal to, that one will be equal to pi d square by 4. Here it will be rectangular, therefore b by d minus, what about area of the steel, which is 2512. If you simplify, you will get area of the concrete value directly, and whatever the value obtained here, you please substitute in this formula. Okay, finally after simplifying all the things, and you will get the value in terms of kilonewton. You please see the conditions, whether it will be Newton per mm square, means change that one into kilonewton also, like into 10 to the power of minus 3, and finally you will get the value in terms of 2919 kilonewton, more or less approximately equal. Okay, then already you people know PU value, which is 1600 into 10 to the power of 3, or else it will be in terms of kilonewton only, no need to convert that one Newton. Okay, then PUZ will be equal to 2919. If you simplify, you will get 0.548. So this is the value of 0.548. So the PU by PUZ value will be equal to 0.548. Okay, so what they used to told in the code, so based on this PU by PUZ, alpha n is related, but here the values will be clearly mentioned, it will be varies like so and so, but for that also there will be one graph. Okay, so later I will uploaded this graph in the description also, so I will make this PDF and kept this link in the PDF description also. If you want, you please download this graph. So here see here, this is the graph related to PU by PUZ. Okay, so actually I already so I will make this PDF and also give this link in the description also. You please download this graph, then it will be very easy to solve this model. So this is related to code only. So your PU by PUZ values will be equal to 0.548. Okay, and what about this alpha n? So just relate this 0.548. So I am writing clearly here, which is 0.548. For that one, you have to relate this alpha n. Okay, see here, this is 0.4 and 0.8. So in between, I am taking two decimals between 0.6, and your 0.448 will be lies between this 0.4 to 5, and again your value will be 0.548, means in between 0.5 to 6. So like that I am taking some relation, okay, here, okay, 0.548. So like that I am dropping a line for that particular value. I am dropping a line. So wherever it will touches the line in the graph, so see the perpendicular value. So if you take down exactly and relate like this, okay, if you draw perpendicularly means, so in the paper it is very easy to find. Why? Because if you keep a scale here and draw a line like this, and for that you have to draw a perpendicular. If you observe the value, it will be 1.2 and it will be 1.6. In middle you can assume the value will be 1.4, and for then you can take 1.5 like that. So your alpha n value will be equal to, choose like this, which is 1.5. So in the formula, entire values according to code will be like mux value will be given the question, muy value will be given the question, mux1 plus muy1 will be find out by using sp16 charts, and alpha n will be equal to 1.5 around. So if you want, you find this value, simplify this value. So take down the formula, that is mux by mux1 whole to the power of alpha n plus mu y by mu y1 alpha to the power of n. That one will be equal to, sorry, which is less than or equal to 1. So take down the values of mux1 which is given in the question, that is 120, and again mux1 which is obtained here, that is 245, alpha n will be 1.5 plus muy will be given as 90 by muy1 will be 153 obtained value, and 1.5 which is less than or equal to 1. So simplify in the calculators. So that is how much you will get, that is 120. So your value will be around for this one 0.34 plus again just take down the value of 153 ratio of 90, which is 0.45. So if you add these two values 0.45 plus 0.34, so you will get a 0.79. So these value will be less than 1 only, so it will be satisfied. So whatever the moments obtained from the graph and whatever the procedure you did also almost correct. Why? Because finally it will be relates, like 0.7 will be less than or equal to 1. Up to 1 you have the chances of getting the value. So this is the procedure for finding these biaxial columns. Okay, then what is our next step? So we know the what is the next step means providing lateral ties and pitch. So we solved so many problems based on the lateral ties to that of the pitch, like in the previous examples also. So roughly provide according to the condition 8 bars with a pitch of 300 Okay, if you want, you can see the conditions for pitch. Least lateral dimensions will be equal to 400, least lateral dimension, that is 400 in our condition, and second condition will be which is 3 times of the longitudinal bars, that is 320, and final condition will be 300 So after solving so many problems, directly you can know that what we have to provide like that. So provide 8 bars with a pitch of 300 So maybe you will get, there is a chance of getting 6 stirrups after solving this one. You can provide that also, no problem. So the condition is not less than 6 and again the first condition is diameter by 4. Here we are using 20 bars, that is 4 means you will get 5 So provide 5 mm also. If you use 8 means 8 also okay. Why? Because least will be 6 mm, not greater than, not less than 6. Then I am providing 8 mm bars, which is safe side only, no problem. So after that, draw the cross section. So I am showing roughly here. So this is the outer dimensions, like 600 this side and 400 this side. Okay. Then I am providing the tie before. Then I am providing the bars for conveniently drawing that one. Okay. Then I am providing the reinforcement with this red bars. So I am providing 4 bars first. Okay. Here also it will be. Okay. Then again 4 bars. Why? Because we are providing 8 bars. And again here also 2 bars. So please provide spacing according to the specifications, but here I am showing roughly. Then you have to draw the, provide the stirrups lateral tie like this also for these 4 bars. So first 4 bars will be like this, you will get, so for 4 bars it will be like this, it will comes like this, and again you can provide like this, and for these bars can come like this, provide like this. Okay, starting coming from like this to like this. So what I am telling means, and again next 4 bars it is better to provide like this. Okay, so like this I am providing. If you want elevation, again you can draw the elevation, and there for particular elevation you please show the lateral tie of whatever you provided, 8 mm or 6 mm, and again pitch. So here it is not, I am not showing pitch. Why? Because for the cross section there will be no pitch, but while drawing the elevation, there for the each and every lateral tie you will get the pitch. Okay, so please draw the elevation also. Already I shown for the previous example. Likewise you have to draw in the same manner. So friends, this is the procedure for solving this type of biaxial bending moments along with cross sectional dimensions. So I hope you understand this lecture. If you really like this video, please like this video, share it to your friends, and subscribe our channel. Thank you so much.